Good afternoon, sir. This is my presentation for radiometer for medical sensing application using two different reference noise source. Uh, uh, yes, sir. I have gone through many papers, and this paper I find more suitable for hot and cold part calibrations. So I have mentioned paper link, and yes, uh, I have studied whatever I have studied in this paper, and I'm going to explain today. uh, First, the abstract of that paper was in this the temperature of the human body. They used to measure using radiometer in a non-invasively techniques, and for medical application they use match and mismatch resisted room temperature as a hot and cold source noise source. And next is they sufficient accuracy for medical application has been found with relatively input temperature ranges. And the frequency they had used is 3 gigahertz radiometer, which contain an antenna collecting the noise power generated by the target. And next is they had amplify of noise power, low noise and high gain receiver has been achieved, which converts the noise power to the voltage via using this detector. And next they had used a switch. This switch is SP3T. Full form is single pole triple throw. This switch is placed between receiver and antenna that process the data to detector and output the voltage and physical temperature reference noise source has been targeted. And the thermometer in the temperature measurement of water, which ranges from 25 degrees Celsius to 43.1 degrees Celsius, radiometer shows a good performance in this. And the purpose was two reference noise source, hot and cold, was used using a match and mismatch resistor at room temperature. Now this is the introduction part. In this introduction part, what I have studied is the thermal measurement of human body. Microwave radiometer is used non-invasively to measure the core body temperature, monitoring thermal imaging of the breast cancer. In early they were had a dick radiometer. Dick radiometer they used traditional techniques. As you can see in this block diagram also, the balance noise source from antenna and reference noise source using a dick switches at the input of radiometer. uh, it is inexpensive, small size, front end edge of radiometer, single reference noise source. Now what was the drawback in this dick radiometer? One load calibration inaccurate. Because of that, the noise figure of the radiometer does not change. And next was it operates in the input temperature ranges from 246 to 316 K. Performance was imbalance between the among the port of SP3T switch, which is the bit which is lies between antenna and receiver, that used to select port among the reference. And An error in temperature also cause, and error are minimized by employing the offset voltage of radiometer output voltage. Now this is the design of radiometer. In this, two reference noise source was low noise and high gain receiver, and amplify input noise power generated by an object. And what the output power was, receiver P out means that W is given as with this equation. P out is a G receiver KB. K is Boltzmann, and B is a bandwidth, and bracket in bracket T in plus T receiver, where in this T in K is stands for K, and T receiver stands for K, are the input. These are the input noise temperature, which is equivalent to noise temperature of the receiver. And next, K stands for Boltzmann constant, that has a following equations, that is 1.38 into 10 raised to minus 23 JK. B is a bandwidth of that receiver, that measure in hertz, HS, and gain receiver W is a receiver gain. And now I'm going to explain this radiometer design, how it has been designed, this radiometer. And first of all, it is a they had a two reference noise source to design this radiometer. Direct conversion receiver has been used, and low noise amplifier consisting of which radiometer consists of LNA and BPF. LNA is low noise amplifier, and BPF stands for band pass filter, right? uh, Detector, and the output voltage has been V out is proportional to the input noise power, and DK is used. What is DK? DK is data acquisition board. It is used for reading this voltage, and process, and this all process is done by using PC and personal computer. And then a noise source has been calibrated using receiver gain. In this cold and hot noise source, that is you can see in this figure also, reference 1, which is at the top, and this here, and reference 2 are implemented using mismatched load at a room temperature, and SP3 switch, uh, that receiver input among two reference noise source and antenna. And next is uh, AOB. AOB stands for analog output board, that generates a switch control signals. And next, they had used a temperature sensor to measure this uh, TS1 and TS2 for measuring the physical temperature. This two reference noise source, and target stands for T, and all the component in this receiver are mounted on single aluminum jig, so that it is assumed that physical temperature of two reference TR and antenna TPA, transmission line which is TI, are all equal. Now two reference noise source. What is this reference noise source? it's a different noise temperature are needed for the two load calibrations. Hot and cold noise source are simply implemented using this mismatch resistor for medical application, and TR, it's a physical temperature that provides an equivalent noise temperature to receiver side with impedance ZO0 as given in this equation, that uh, temperature reference equal to impedance minus uh, R reference upon 0 plus R reference. and and this relation is based on cold and hot noise, and which fabricated using mismatched, the reference first reference value is 22 ohms, and the match reference reference 2, that is 50 ohms respectively. Therefore, the value of for a T reference reference 1 becomes 0.849, and TR and TR reference 2 equal to TR. Now the TR reference 1 value is 24K, and TR reference reference 2 value is 290K, and TR equal to 290K. In this this temperature resistant, which is a physical temperature, is measured using a temperature sensor TS1, and this is the whole uh, two reference noise source about. And next is the SP3T switch calibration. Now what is this SP3 switch calibration? As I said before also, in about second slide, about SP3 and how they had used in their design also, but this is a calibration part. In this SPIT switch has a receive which selects a among port among two reference loads and an antenna, and it has been assumed that SP3T switch exhibit the same characteristic in three throw port term of insertion and return losses. However, in the real SP3 switch can performance imbalance among three ports. This may leads to accuracy in calibration process, and loss of imbalance switch can be considered in this calibration of radio, and the performance imbalance among the port are compensate by adding the different offset voltage for each port to generate same voltage, and when each port is terminated with the same 50 ohms load. Now this was the SP3 switch calibration. Somewhat I have given a details which I have studied in that paper, and next is receiver design. Now in this paper I have also studied that they had a design, and they have also shown a real photograph. They have shared this photograph receiver design, and they had a block diagram for direct conversion receiver, how they had made this in this the medical radiometer carefully determine the operating frequency that consider a partial resolution and penetration depth for the electromagnetic wave in human tissues, and a few frequency a low frequency band around with deep penetration, deep in desirable temperature measurement for core body temperature with thick loosely tissue layer. As you can see in this figure also, they had a direct conversion receiver operating at 3 gigahertz, 3 LNA is used with the ZX, it was mentioned which LNA, ZX60 36 2GLN, and mini circuit with gain of 20 dB and noise figure of 0.9 decibel and 4 bpf means band pass filter is used, 2.4 dB, which band pass, the number of band pass that BFCN 3010. And again the mini circuit was used, properly inserted between LNA and LNA, as said, that is low noise amplifier to limit this bandwidth the receiver. And the SP3T switch number was SKY 1334536 Skyworks exhibit insertion loss was 0.8 dB, around same 3 gigahertz was 3 gigahertz frequency. And this all requirement was there for the receiver architecture, in the receiver architecture. And this and they had used this frequency band for measuring the temperature of human breast and brain using this radiometric. Okay, next is this is a temperature measurement setup, how they had set up this, how to measure this temperature, and how they had made all this setup. In detail I'm going to explain how they are had set up all this. First of all, several measurement setup has been introduced to validate the performance for medical radiometer. In such homogeneous water NaCl solution branches, and by measuring the temperature of heated water in bath, uh, emissivity of water is calculated using 0.98 funnel reflection coefficient or at water air interface. And as you can see in this figure, the experimental setup, water bath styrofoam, that light gray in color, uh, dielectric constant of 1.03 is covered with curtain 60 dB attenuation on the top, and aluminum container at the bottom. And a horn antenna is placed on 20 centimeter above the water level, this water level surface. And as you can see, temperature sensor also calibrated thermocouple using high precious thermometer, bat 10 by fixed temp, and two reference noise source antenna SP3 switch. Each detector voltage was sampled by DAQ, as I said, to process all this data acquisition board, um, and a PC to detect to process this data. And detector voltage were averaged every 250 samples to determine this receiver gain. that's it. I have studied in this paper. uh, Thank you for the day.